Alright, here we go. We are on section 13.3 today, and we're talking about evaluate trigonometric functions of any angle. And so we'll see how we do on this stuff here. The first thing up is the unit circle, and I put a little picture of the unit circle here on the left. I hope all of you have taken a look at my video on the unit circle. It's on the 13.3, section 13.3. I went through the entire unit circle and filled in that whole thing, and you really should do that because that's what's going to be the thing that's going to strengthen you and put you over the top. Essentially, the unit circle is this: x squared plus y squared equals 1. It is the circle that's formed when you do that there. The quadrantal angle, that is any angle that's in standard position where the terminal side is on the x-axis. Okay? And a reference angle is the amount of degrees that it is as long as it's back here on the x-axis. So we'll talk more about that in just a minute. Let's take a look at these things here. When you look at the unit circle, or when you look at a circle as it goes around, I like to do. Let me scoot this guy out of the way real quick. What I like to do is I like to draw my triangles that are formed. And so when I look at that point that's over here, x, y, I see a triangle that's formed right there. So I look at that triangle and I put the theta down in this corner, and I say the sine of theta. And when I'm looking for this, I know what I have is a right angle right here, and x is up here. I have the point xy, which tells me that the length of this side was y and the length of this side was x, and the radius is r. So when I'm trying to find the sine of theta is going to be opposite over hypotenuse. And the cosecant is going to be the hypotenuse over the opposite. The cosine is going to be x over the hypotenuse, and the hypotenuse over x. And tangent is kind of tricky. Now tangent, if you could remember this would help you a ton. Tangent equals sine over cosine. Anytime you're dealing with tangent, if you did the sine, if you find the tangent of 25, it would equal the sine of 25 divided by the cosine of 25. So what we have here is the tangent of theta actually equals y over r divided by x over r. Well, if I multiply the top and the bottom by r over r, I end up with y over x. And cotangent is simply x over y. Alright, now on example 1 here, if we take a look at where this is in space, we'll see if we can kind of maneuver our way through it. If r equals the square root of x squared plus y squared, alright, think of that with the Pythagorean theorem in mind, a squared plus b squared equals c squared. So I'm going to drop a line right here. And that's what I have. I have a little triangle. I have a triangle that has length 12 on the bottom and 5 here. Okay. And if I'm trying to find my r, then I simply put the x and the y. And now the x happens to be, in this situation, negative 12. Well, when I square it, it won't matter. And the y happens to be 5, so that's 5 squared. Negative 12 squared is 144. Plus 25 is 169, which results in 13. The square root of 169 is 13. So when I'm trying to find the sine of theta, now I know 13 over here. I can figure that out by doing opposite over hypotenuse. Opposite would be 5 in this situation, but I guess they want us to put the y. Okay, so I end up with 5 over 13, and cosecant would be 13 over 5. Alright, now cosine, remember the whole A smart trig class we talked about in the unit circle? This point up here, sine is going to be positive, so sine was positive, 5 over 13. Everything else is going to be negative. Cosine, secant, tangent, cotangent are all going to be negative when I'm done with them. Because remember, this line down here is actually negative 12, not positive 12. So this one is going to be your x over radius, which my x number is negative 12 over 13. This one over here is going to be 13 over negative 12, or negative 13 twelfths. Your tangent ends up being opposite over hypotenuse, which is your y over your x, or opposite over adjacent, sorry, which is 5 over 12. And your cotangent ends up being 12 over 5. Alright, you guys go ahead and take a look at checkpoint number 1 and see how you do. Just pause it for a sec. Alright, so hopefully you were able to draw this. What I would do if I were you, I would draw this thing. I would go to 6, negative 8. So 6, negative 8 is, I don't know, somewhere around here. Alright. And I draw myself a triangle. Okay. And I would use that x-axis as, that's where I'm going to put my theta. That makes this length over here 6. It makes this one right here negative 8. So the first thing you have to do is a squared plus b squared equals c squared. And some of you see that that's a 3, 4, 5 triangle. Right? 3, 4, 5 triangle. So this must be 10. Alright? Some of you don't see that, so you went through and did 36 plus 64, and you got that to be 100. And then you square rooted it, and you went, oh, it's 10. Okay? And so when I'm going through and I have sine, and I have cosecant, and I have cosine, and I have secant, and I have tangent, and I have cotangent, I hope that you were able to do sine is opposite over hypotenuse, so negative 8 over 10, or negative 4/5. 10 over negative 8 was your cosecant. Your cosine, 6 over 10, it's going to be positive, remember, because a smart trig class knows that cosine is positive down here in quadrant 4. This one's going to be 10 over 6. Tangent is going to be opposite over adjacent, negative 8 over 6. And cotangent is going to be 6 over negative 8. Alright, hopefully you got those. Let's take a look. Now the unit circle, just like I said before, this was all I put all of this on that additional thing, but here's the major stuff you need to know about it. In the unit circle, the sine of theta equals y over r, and because the unit circle is always 1 unit in radius, then the sine of theta is your y number, and your cosine of theta is your x number. And that's really where sine and cosine originate. If you really are wondering, what the heck is this sine and cosine? It's how they determined where you are in location around a circle. That's where it came from. So the location around a circle might be important to you. So that's where that all... Alright, let's take a look at example 2 here. In example 2 it says use the unit circle to evaluate the 6 trigonometric functions of theta being 450 degrees. And so if I think about 450 degrees, that means I go all the way around one time plus another 90 degrees. That means I'm right up here, top of the world. And so what do I know about that right up there? What's the y value? Sine? Well, that's 0. Cosine would be, the y value up there is 1. That makes the cosecant value 1, because it's 1 over 1. The cosine value is 0 over 1, or just 0. But when I put it into secant, it ends up being 1 over 0, which is undefined, or does not exist. Remember what I said about tangent being sine over cosine. That's 1 over 0, undefined. However, cotangent is the opposite of that, 0, or the reciprocal of that, 0 over 1, which is just 0. So that 450 is not the hardest one that we've ever done, but having the unit circle would definitely be beneficial. Alright, you guys go ahead and do checkpoint and do the 6 trigonometric functions for 360. Shouldn't be too tough. Alright, so you had sine, cosine, tangent, cosecant, secant, cotangent, all of 360 degrees. So theta. We're just going to call that theta for right now. Alright, at 360 degrees, my y value was 0. So if we called that 0 over 1, cosecant would be 1 over 0. One over 0, undefined. Cosine was 1, therefore secant was 1. Cotangent would be sine over cosine, which is just 0. That's tangent. And cotangent would be 0, or would be 1 over 0, undefined. So the big thing to understand is that cosine goes with x, sine goes with y. Alright, let's take a look at this next page here. The reference angle relationship. Reference angle relationship is how do these things go together? What's their, and we talked about this in that unit circle. How do these things go together as you move around the quadrants? Okay, so let theta be an angle in standard position. The reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. The relationship between theta and theta prime is shown below. Boy, this is a lot of stuff that's kind of tough to grab onto, but as we look at it, just understand that we're going to do some examples, okay, and it'll get easier as we go. So as we look at this in degrees, when we're looking for theta prime, its reference angle is going to be 180 minus theta. And essentially what you want to do is you want to look at how far it's from the x-axis. That's what's going to tell you your reference angle. My distance back to the x-axis, because we're referring to the angle that's over here in quadrant 1. So if this was 30 degrees, then we'd be referring back to this 30-degree angle. And if theta prime down here was 42 degrees, we'd be referring back to 42 degrees up here. And if this down here was 57, we'd be referring back to 57 degrees up here. So referring everything back to quadrant 1. Alright, so when it says find the reference angle of negative 165, I look at it and I go, okay, negative 165 is negative, so it goes this way. It's 15 degrees from here, so if I'm 15 degrees from the center there, then my reference angle must be 15 degrees. Okay. And there's a few different ways to look at it. You could say, oh, negative 165 is positive 195, still 15 degrees from 180. That's how you're going to get 15. Okay. And if you look at B, the 7 pi over 4, well, let's take a look. Let's see. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 is right down here. Well, it's 45 degrees from the center, or pi over 4 from the x-axis, so its reference angle is pi over 4. Alright, when we're evaluating these trigonometric functions, I talked about this in that other video, that supplementary video. A smart trig class knows that the only thing that is everything is positive in quadrant 1, but the only thing that's positive in quadrant 2 is sine and cosecant that goes with sine. Down here, tangent. Over here, cosine. A smart trig class knows. You got to memorize that. Alright, example 4. You want to use the reference angles to evaluate this. So if I'm at negative 125, negative 180, negative 125, we're right here. And I'm trying to find the cosine of negative 125. Well, that's 45 degrees from here. Okay. The cosine of 45, when you put that in your calculator, you're going to get this thing that says 0.707. You need to know that 0.707 is always referring to the square root of 2 over 2. Okay? Square root of 2 over 2. Now, the square root of 2 over 2, that is a good answer. However, a smart trig class knows if I'm over here, cosine is negative. So it's negative square root of 2 over 2. And 10 pi over 3, the cotangent. Wow, that's a cotangent gets a little tough, doesn't it? The cotangent of, first of all, let's find 10 pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6 pi over 3. Oh, I messed that up. Hold on a minute. I was thinking of pi over 6. Let's try that again. Pi over 3 is like 60 degrees. So let's do that again. Pi over 3. 60 degrees, 120, 180. That's 3 pi over 3s. 4 pi over 3, 5 pi over 3, 6 pi over 3. There's 2 pi. 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3 right down here. So it looks like I'm 60 degrees from the base there. Okay, so if I'm 60 degrees from the base, I'm really, and when I'm dealing with cotangent, I like to talk about tangent. So if I'd say, what's the tangent of 60 degrees? They say you're supposed to memorize it. You know, what I say is, I don't know that I want to memorize that. But what I do memorize is that tangent of 60 degrees equals the sine of 60 over the cosine of 60, and I know I memorized those. I know that the sine of 60 is the square root of 3 over 2, and the cosine of 60 is 1/2. So I multiply the top by 2 and the bottom by 2. All the 2's go out, and the tangent of 60 is the square root of 3. However, I'm not looking for the tangent of 60. I am looking for the tangent, the cotangent of 60, which is 1 over the square root of 3. 1 over the square root of 3, which you cannot have. So I'm going to multiply the top and the bottom by the square root of 3, and I'm going to get the square root of 3 over 3. Wow. That's a tough one. That is for the champs. Alright. Find the reference angle for 150. Hopefully you say, oh, 150? That's 30 degrees from 80. My reference angle, 30 degrees. Evaluate the secant of 300. Evaluate the secant of 300. That is all the way over here, 60 degrees from the center. Secant goes with cosine. A smart trig class knows that cosine and secant are positive down there. So I'm going to do the cosine of 60 equals 1/2. The secant there is then 2, because it's the opposite, it's the reciprocal. That was a long, tough unit. Thanks for hanging around.